This is a story all about how our double helix DNA became unwound, and I'd like to take a minute, just sit right there while I tell you all about how nucleotides make us stare.
In DNA synthesis, aka the S phase, DNA's replication process starts with helicase. Chilling out, maxing, relaxing, all cool. Helicase unzips hydrogen bonds like a tool.
When a couple of enzymes, they were up to no good. RNA primase started laying down nucleotides like we didn't know it could. Leading strand. RNA primase needed just one little start and it got scared. It said, I'm leaving lead and letting DNA polymerase get flared.
Lagging strand. DNA polymerase begged and pleaded with lag all day after day. Said, why you gotta be so difficult, eh? RNA primase came by to help out the DNA polymerase. Not just once, but at each Okazaki fragment starting place.
Lead whistled for lag, and when he came near, he said, get away, you don't belong here. The SSBP makes sure of that. Ligase finished up the sugar phosphate background lab, and lead now had daughters of their own.
Two separate DNA double helix structure seen, A to the T and G to the C.
Word.
Hold up.
DNA is a double helix. Each strand is comprised with nucleotides that are held together by hydrogen bonds. One strand will move in the 5' to 3' direction, and the other will move from the 3' to 5' direction. This explains how the two are anti-parallel. The nucleotides on each of the double helix strands contain adenine, thymine, cytosine, and guanine. An enzyme called helicase separates the two DNA strands by breaking the hydrogen bonds on the nucleotides. Single-stranded binding proteins attach to the templates to keep DNA separate. In front of the helicase, the enzyme topoisomerase attaches to the strand and relieves tension and anxiety. The replication fork is the site where the DNA is being separated. The DNA double helix is separated into two strands, each strand going into a different direction. The leading strand is read from the 3' to 5' template, and the lagging strand is read from the 5' to 3' template. An RNA primase, which is also an enzyme, lays down RNA primers. Its job is to start the process of DNA synthesis. During replication, the leading strand will be synthesized from the 5' to 3' direction, and the lagging strand will be synthesized from the 3' to 5' direction. The DNA polymerase, which is also an enzyme, adds nucleotides to the new DNA strand. More RNA primers are on the lagging strand and separate the strand into segments called Okazaki fragments. As the DNA polymerase fills each segment, it also removes the RNA primers. The gaps and fragment of the new daughter strands begin to close and are finished off by the enzyme DNA ligase, which its job is to complete the sugar phosphate backbone for each daughter strand. The replication process is now complete, and each new strand molecule is a double helix, each having one parent strand and having one new daughter strand. Each new DNA molecule has the same genetic information as the original DNA molecule.